Okay, so first is differentiating inverse functions. All right, so an inverse function property, if you'll recall, we learned in pre-cal, if f and g are inverse functions, they have this property that if you take the compositions of each other, you end up with x. So f of g of x equals x, and also g of f of x equals x. That's a property of inverse functions. Hopefully you remember that. You do need to be somewhat familiar with that. On the AP test, that might show up as a concept sometimes. They might not explicitly say that f and g are inverse functions. They might say that they have this property, and you have to deduce that they're inverse functions. Okay, so a lot of times this is more of a conceptual question. You don't have much actual computation that has to happen. It's just a concept. So let me show you where this derivative rule comes from. So if I wanted to take the derivative, if f and g are inverse functions, and let's say I want to find the derivative of the inverse function g. So we have this property, f of g of x equals x. Let's go ahead and take the derivative of both sides. So if we were to take the derivative with respect to x of both sides of this equation, those would also be equal. Okay, so if they're inverse functions, they have this property. And now I'm going to take those derivatives, and those derivatives would also be equal. So this left side, what rule is that? Chain rule. So we have the outer function f. Chain rule says, so this derivative of the outer function of, keep the inner function the same, right? F prime of g. Then chain rule says times the derivative of the inside function equals the derivative of x with respect to x. That's just 1, right? Everybody good with that? Any questions so far? Okay, so now what we're trying to find is the derivative of an inverse function. So if g is the inverse function of f, if I want to find the derivative of g, well, that's just this guy right here. That's g prime, right? So if I want to get g prime by itself, then what do? I have to divide by this term, f prime of g. Okay, so if I divide by that term, then g prime of x, if f and g are inverses, would be described as 1 over f prime of g of x. Now, that is the derivative of an inverse function. So now I want to show you a different notation, though. Another notation, if you have an inverse, so an inverse of f is also, you could use this notation, right? The -1. So it's not an exponent. It is in the superscript where the exponent also is, but if you put it on a function, it means the inverse of the function. It doesn't mean to the -1 power. Everybody agree with that? Okay. So I just want to show you another way. It's really clunky notation, but you might also see it on the AP test, and I want to make sure that you're okay with seeing it. So instead of using g as the inverse of f, let's use the notation inverse of f. And you'll see right away why it's clunky. So if I want the derivative of f inverse, here's how we denote it. You have to be very careful. You've got to put parentheses around that inverse, then you put the prime of x. So you've got like the -1 and you have the prime. So you've got two things going on there in that superscript area. So the way you do that is you throw parentheses around the f inverse and then you put the prime on the outside. Okay? So that's the notation for the derivative of the inverse. This is another notation. So if I didn't say that g was a derivative, if I didn't say that g was the inverse of f, if I just used f inverse is the inverse of f and I didn't introduce another variable, I'm just showing you a different notation. We're not even bringing in g. So the other notation, if I want the derivative of this inverse function, then it'd be 1 over f prime of f inverse of x. Okay, so that's a different notation. That doesn't happen as much, but I have seen it appear on the AP test. Like I said, it's really clunky, but I just want you to be familiar. So these are both the derivative of an inverse function using different notation. One's introducing saying f and g are inverses. Another one's using that inverse notation. Number 1, if f and g are inverse functions, and I'm given f, find g prime of 3. Now here's why we have to have a formula for the derivative of an inverse function. Because if I just gave you this problem without talking about the derivative of an inverse function, many of you would just try to find the inverse function, right? How do you find an inverse function from pre-calculus? You would switch the x and the y variables, right, and then solve for y. Well, think about this for this problem. If I switch the x and the y on this function right here, if I said x equals y, you don't have to write this down, just watch. If I switch to x and y and then try to solve for y and take its derivative, can I do that? Can I solve that for y? No, I cannot. Okay. Some of you might be like, well, can I just use implicit? That might get a little bit trickier. So there's a way to do this if you're talking about an inverse function. So if I want to find g prime of 3, so f and g are inverses, I can find f prime of 3, right? Because I'm given f. But how do you find g prime of 3? Okay, as soon as I see this phrase right here, the very first thing I write down is I say, okay, if I want g prime of 3, I look at my formula, and I go ahead and say, okay, that's going to be equal to 1 over, look at the formula, g prime of x is equal to f prime of g. So this would be 1 over f prime of g of 3. Does everybody agree just following the formula? Do you agree with that statement? If f and g are inverses. Okay. So it's f prime of something. Now, I can find f prime, right? I can find that derivative. The problem is, what is g of 3? Oh, I meant to change color. What is g of 3? Okay, what does that mean? Okay, so off to the side, so what I'm going to do is g is some function where if I input 3, I'm looking for its output. Do you agree with that statement? Whatever's in the blank is what I'm looking for. Now, if f and g are inverse functions means their x and their y's are switched. So that means for f, the point would look like this. Do you agree with that? If f and g are inverses. So I'm given information about f. I'm not given information about g. So what that means is if I want g of 3, I want to solve for what is x when f of x equals 3. That's what g of 3 means. Does that make sense? Okay. So I've got to figure out what is x when the y value on f equals 3, which is with the x value of g. Now, here's my function f. So I've got to figure out when is f equal to 3. Now I'm going to go ahead and tell you, solving for this, we already said we couldn't solve for that variable. You cannot solve for x here easily. What you have to do is the ones that you're going to be given are easy enough to just guess and check. Okay, they're going to be easy enough to just guess and check. So just guess and check. What value of x would make that true, that equation true? How in this equation, if x is 1, 1 cubed is 1, plus 3 times 1, minus 1, you get 3. Everybody good with that? Okay. So my question was, so what is x when f of x equals 3? X is 1. So now I'm going to go back and plug that in. So on f, I have the 0.13. So that means for g, I have the 0.31, since those are inverses of each other. Everybody good with that? Okay. So now that I found g of 3, now I can bring that back into my equation and say, okay, g of 3 is 1. So now I'm looking for 1 over f prime of 1. Okay. So now I just need to find f prime and then evaluate that at 1. So it's kind of like, it's like a back and forth kind of thing with the inverses. So let's find f prime. Just a little power rule. Okay, so I'm trying to evaluate f prime of 1. So we end up getting 6. So my final answer is 1/6. You see how the math wasn't hard, like the actual computation, as opposed to last lesson, we had a lot of mathy math. This is more conceptual and understanding what's the right step. Sometimes can be harder, simple, but difficult. Okay, I'm going to pause. Any questions now that we know we're not looking at the table?
For that guess and check type thing,
Yeah.
like, will you make it kind of apparent on test questions that it's going to be something where we can really guess it?
Almost all the time, if you're given a problem like this, where I give you a function, the actual function equation, you will have to guess and check, and it will be fairly easy. If it's not easy, they'll give you the point, and you'll see that in your problem set. There's going to be some functions where they just say, this is the point.